our script. So the first thing I was getting into was, let's see if we can't build our first little script tag. So I had a simple little hello world here. Ideally, you're going to use your Minesweeper app instead of my fake HTML here. But we'll start with the simplest thing of all, and let's create a variable down there. I'm going to put it in my script tag in the live share here, just so that we have something in there that we can see in the debugger. Let's see if I can make the inspector show up. Yay. So I'm going to reload that. And I'm going to put a breakpoint on line 74. And over my browser, I'm just going to hit refresh. And when it does, we get to see the debugger work. So it's loaded all the HTML. It's in the script tag. It hit the breakpoint. My breakpoint's listed there. If I click on it, it'll take me right there. If I'm up here, click on it, it takes me right to it. And it's going to show me under the scope what variables I have. It's going to show me all the global variables, which, ick, ugly, I don't want to look at that. And it's going to show me my variable A that's currently undefined because this line hasn't happened yet. And if I step over it, I now see that A is the value 42. Of course, my script is about to exit, and nothing is going to happen from that. And I can just push play and let her run. And I get my page. So using those tools, we can start to build our applications. We have HTML to give us some structure. We have CSS, which by now you figured out you could twiddle and play with CSS and burn every hour of every day and still never get it exactly perfect, because futzing around with CSS is a very time-consuming thing. And then we add some script to add the interactivity. My suggestion here as you're building applications is that as we go forward, and try and do this with Minesweeper, get the HTML and the CSS done as quickly as possible. We really want to focus on the programming, but we need that structure to hang the programming off of. So when we get new assignments and new applications to build, right? The process is, okay, how am I going to solve this? Sit down on some paper, diagram out what I want my app to look like, diagram the user interface, implement that as boxes in HTML, spend a night with CSS and get it looking roughly the way you like it. And then we're going to dive into the code and make it functional before we go back and play with the CSS and make it perfect. Right. Okay. Blocks in JavaScript. Having a single variable is not much fun. It doesn't do anything. So blocks are denoted by curly brackets in JavaScript, just like they are in C++ and C#, so that should be easy and straightforward. When we declare variables, we typically initialize them right away in JavaScript. And here I'm using all of the typical scope keywords. Most variables we use are going to be let variables. This is something I'm going to change. Right? Here's a variable. It's variable, which means it can change. Using the var keyword is still perfectly acceptable to the language. That's one of those things I never want to see in your application. If I start seeing a lot of them, I'll just start taking marks off every time I see the keyword var. There's zero reason for using it ever in a JavaScript application. It's there for historical purposes and nothing else. Const, we're going to use all the time. And just like you would use constants or defines in other languages, constants can be true constant variables. So instead of having magic numbers in your program, put a constant instead. How big is your Minesweeper grid? That's a constant. It's 15 rows by 15 column. Grid size, grid size, 15. That way, when I tell you to change the size of the grid from 10 to 15, you change one number. You don't go hunting through a whole bunch of loops to find out where that number 15 is. We'll use it later as we do more elaborate things with objects. And obviously, when we start playing with objects, we're going to start using the this keyword a lot. Unlike other languages, there isn't really a shortcut that lets you carve the this keyword off. In this instance, what I have here, the this keyword, also uses an operator. And just like the plus sign or the equal sign or the minus sign or plus plus, the dot in JavaScript is an operator. It modifies something, it changes something. In this case, it's called the dereference operator. So this is an object, and the dereference operator, the dot, accesses a variable called member that's inside whatever this refers to. So this is a pointer.
So I can create an object, like scope object, and inside you have a lot of left variables, so I access them with that.
Yeah, when we define objects, I'll show you how we do that. Okay? So, avoid global variables because other pages, other sites, and other applications can access them, which means they can change them. And that's bad for your program. Okay? JavaScript is loosely typed, and that means certain things happen in slightly weird ways. So, first of all, my integer and a float will declare as two separate variables. JavaScript doesn't see these as different. They're both numbers. Here's another number. If you want a floating point number, just use the number. You don't need to put the decimal point in. You don't need to put a fancy F in or a 0 in. JavaScript is smart. It goes, oh, this is a number. And if you want to use it like a floating point number, use it like a floating point number. If you want to use it like an integer, use it like an integer. Why should you have to care? It's a number. Another thing it does is really intelligent. You notice none of these variables have types on them. Because JavaScript says, oh, well, you assign 12.2 to this. Well, that's just a number, and it's a floating point number. Why do you have to tell me that? You don't. You don't have to do that extra typing. You don't have to assume the language is stupid. Is another float a floating point value? Yes. Is it a number? Yes. Is it an integer? Yes. Do you care? No, it's just a number. Let's have some fun. Okay? It's totally cool to do stuff like this. Is that okay? Why not? What brainwashing have you gone through?
The C# one.
Yeah. So what would be initialize me after that? Yeah, it'd be hello 5. JavaScript's totally cool with that. Right? It just kind of makes sense, right? How about this? Is that okay?
Yeah. The name doesn't matter.
Right. Is that okay? Yeah, that's totally cool. Is this okay?
No. Can't say it.
Does that work?
No.
No. Why not?
Because it's not a number.
Right.
You can't use operators on words.
Yeah, you can use operators on words.
Well, if they're not like, if they're variable words, and the variables have like a number.
We use variables on words all the time. Not exactly. The thing is, JavaScript's trying to be smart, so it's trying to convert things for you. So in the first case, where you have a string called hello, and you add the number 5, JavaScript says, hey, here's a string, and you want to add the number 5 to it. Well, I know how to convert the number 5 to a string. So it just adds the string 5 to the end of hello, so you've got hello 5. In the second instance, you've got a number, which is 11, and you're adding a string to that number 11. So when it looks at the number, it says, can I convert the string 80 to a number? And it doesn't know how to do that. So that's why it fails, and it can't make those things. Now already I can see your brain scratching at your C++ brainwashing, going, but wait a minute, the types don't match up. It's not, can't. Yeah, you can. Right? It's like, stop trying to overrule the computer. The computer is smart enough. It knows what to do. Okay? But if you know how it's going to combine things, then you can avoid some of the simple, straightforward errors. It does enforce a little bit more programmer discipline. You have to figure this stuff out on your own. You can't rely on someone else who wrote a compiler that's going to tell you all the rules. Okay, we've been through our comments. Ooh, that was the wrong one. I am missing stuff here. There we go. Back to there. Let's go to the next one. Let's go here. And then we can start to put some pieces together. Okay, so while variables are fun, you can't do much without doing some sort of logic in your program. And that's what flow control is. It's all logic. So when your program executes top to bottom, the sequence in which we put our statements determines what order things happen in and what we manipulate. We may want to carve some of our stuff out into separate files, which we'll probably do by the end of today. And then within each kind of script that we build, we're going to have some logic. If this happens, do that. When this happens, do this. Okay? And that's all considered flow control. It's all about making those tests. And it's the same kind of idea that you would use in every programming language. You're going to use some conditions you're going to test. And if that condition evaluates to true, you do the thing in the block. And if that thing evaluates to false, you skip the block. Or while the condition is true, you do what's in the block. Otherwise, you get out of the block. Now, the block is just a replacement for a single statement. So you can use single statements in their place. Almost every condition that you use is got to evaluate to some Boolean value, some true or false value. And in JavaScript, there are actually true and false keywords that you can use. The trick here is, just like other programming languages, when you use things that evaluate to Boolean expressions, you don't ever have to equate them to equals or equate them to not equals. So you don't equate them to equals true, or you don't equate them to not equals true. That's implicit. The thing that's a little bit different is that JavaScript retained the evaluation for numeric values that C and C++ have, which is while there are keywords true and false, there are numeric values that also equate to that. In JavaScript, anything that evaluates to a 0 is the same as false. And anything evaluates to positive, generally positive 1, is true. So you can hook up conditionals that do numeric calculations. And those numeric calculations, if they evaluate to 0, it will skip out or avoid that conditional. Now, that conditional true-false test also requires us to have some ability to manipulate Boolean logic or true-false logic. And that's typically done with the keywords and, or, and not. Is everyone familiar with Boolean logic? You should be pretty close with this, right? True and true is always true. True and false, or false and true, is always false. And obviously false and false is false. And if you're using an or condition, it's when any of the two operands are true, the whole condition is true. In JavaScript, the double ampersand, the double vertical bar, and the exclamation point specify and, or, and not. So double ampersand is A and B, and double vertical bar would be A or B, and the not sign, the exclamation point, you use to invert something. So you can use not equals, or you can use not A and B. We're going to try and keep those conditionals fairly simple. And there is an actual conditional statement in JavaScript. That's a short form of an if statement. I'm going to suggest you stay away from it. Not because it doesn't work, not because it's inefficient, it's just not as readable. That's the only reason. So I will show you what it is when we do some if statements, but it's a shorthand. In case those things aren't solid in your brain, here's the usual charts for and or conditionals. So true or true is always true. In fact, the only time you use an or conditional is when one of the two things, or when both things are false, as it comes out false, and true is the opposite side. So how does the syntax look in JavaScript? Conditionals go inside parentheses, and I have a block afterwards. You'll also notice I do some crazy things with the curly brackets and where they go, which is very not C++, C#. And there's a good reason for it. So when I start putting this stuff together, you'll see style-wise, I always put a space between the keyword and the parentheses when it's a keyword. If I'm writing my own methods or functions, I won't put a space between the end of the name of the function and the parameter list. And that's a visual cue to me that this is a keyword versus this is one of my own functions or methods. The other thing is that while I'm showing you the else here, in almost all cases, you want to avoid else clauses. And you do that by taking whatever the else clause is and you setting it first, and the if conditional overrides it. And again, I'll show you this as we go. And the reason we want to do this ties back to what we did in the operating system class. Remember doing that weird conditional in the assembly language? If jump not equal to 0. Okay? If you do an if and then an else, what you're really telling the assembly language is, if this condition equals true, right? If this condition evaluates to a 0 or to a non-zero, go to here. The else creates another if to test. If this condition equals 0. So an if-else statement actually gets turned into two separate comparisons and two separate branches. Whereas if you can avoid the else clause, you can avoid that comparison. And comparisons are relatively expensive in the CPU. In your game program, moving one else clause out is not going to make a radical difference. But because in our game programs, eventually your game is trying to run at 60 frames a second, which means there's certain things you're doing and you have a very limited amount of time to do it. 60 frames a second means you have 16 milliseconds. And the drawing of game software typically takes 10 to 12 milliseconds, the rendering part, which means you'll often only have 3 to 5 milliseconds to do all of your computation and calculation for your game. So if you can save a little teeny tiny bit in that tight loop, it runs really, really fast, and you can make that habit, then when you start writing game code in tight loops, it will run faster. That'll give you more time to do other stuff. Now, sometimes an if condition isn't enough. Sometimes you need more. So when you need more, you can do a whole bunch of nested if statements, which is really painful to sift through, right? So instead, JavaScript implements a switch mechanism that's like a multi-part if. And that multi-part if says, test the condition and compare it against each of the cases. In this case, my condition should evaluate to a number. And if the value is 1 or 2, do something. Those breaks break out of the block. So this is the most appropriate place to use a break statement and nowhere else. And when we're breaking out of the block, recognize that nothing else will happen after the break. Also, when you use a switch, make sure there's always a default section. It's usually an error handling or a catch-all, but the people that don't put defaults in are also the ones that inevitably, if my condition would evaluate to 72, what would happen? God knows. It's weird. So instead, I just put a default section in just to catch that. All right. Let's put a little bit of stuff inside our JavaScript. So if I go to the live share, I've got some variables. Let's do a const. Right? Now let's do it this way. So just a quick note, you'll see this on the formatting. If you look at the live share, with a conditional, I'll put a space here. Okay, just to let me know it's a conditional. I also have the syntax highlighting on mine set up to color code them slightly differently. I'm going to use the column size as a test. I'm going to put the curly bracket on the same line, so it's kind of out of my way. But I often leave a blank line here, or I'll use that line for any comments for this block. Let's do something. All right, so a couple of things you'll see. I have an if statement, and that if statement has just one statement that follows it. So every if statement has just one statement that follows it. A compound statement is a block. So if I want to do more than just that, let C equals hi there, I put it inside a block. I leave these blank lines for readability, and you'll find them everywhere. Again, just my style because it's easier to read. I use 4 spaces indentation because the gospel of GitHub says that 80% of all programmers expect 4 spaces. The default editor typically is set up to do 2-space indentation for JavaScript and HTML. And I find that 2 spaces is kind of hard to see. So I just save my eyes a little bit and line it up with 4 spaces. Right? And you can set that in the settings of your VS Code. These are things to play with. Just flip there so you can see it even if you're not looking at the live stream. Now, my Minesweeper doesn't really do much right now. And that's because our script doesn't do much of anything. I've got a table, and the table is full of table IDs and table rows, but that table really looks pretty ugly. So if I go back to here, you can see my table doesn't really show up at all. So I'm going to modify my table a little bit here. And I'm just going to do this inside the one index file for right now. I'm going to change the TDs to have a specific size. Sure. Okay, so my grid's starting to show up. I'm going to zoom in so you can actually see it. And it's still pretty boring. So we're going to do a little quick style here. Let's do something slightly different. Let's go left. Cool, right? Little things here. Great. I'm going to make them a little bigger so we can see them. I got little buttons we can work with now. And so we can start to think about, okay, Minesweeper, what do we have to do? One, we're going to have to initialize this grid. So aside from my little test code, Software Development 101, top-down design. That means we're going to write our code by writing the comments first. So what are the things I have to do to start up Minesweeper? Initialize where the mines are, right? Here's a trick. I can't put stuff in the HTML or the CSS to identify where the mines are, because otherwise anyone with the inspector will be able to find them and cheat. That's not cool. So we want to hide those somewhere. I want a mine field. What do I want it to be? I want it to be an array or a list of things. The way we declare arrays in JavaScript is by using the square brackets. Now here's a couple things that will make life both easier and harder. JavaScript has one data structure. It's an array. It comes in one size, one dimension. The upside of JavaScript arrays, and technically from a data structures and algorithms point of view, they're actually dictionaries. But JavaScript arrays can be added to and removed to at any time. You can make them bigger or smaller as you need. You don't have to know how big they're going to be in advance. And you can have anything inside them. So to make a two-dimensional array, we're going to make a list inside each element. And how do we do that? Well, we're going to have to do it programmatically. So I'm going to have to create each row inside the minefield. The idea with this top-down design and writing the comments first is I don't necessarily know how to do all these things. But if I write the comment in, I know what I'm going to try and do here. Okay. So I'm going to assume I have this minefield. I'm going to update the HTML to match the minefield data. In particular, my HTML code has a lot of HTML here that's very repetitive. And I'm a lazy programmer, so the idea of cut, copy, pasting stuff just seems like a great way to take the error I made and copy and paste it into a bunch of different spots. So I'm actually going to turn around and we're going to generate this. We're going to create the minefield HTML. And to do that, we're going to need to know how do we integrate our JavaScript with the browser. How do we get JavaScript to talk to the HTML? Okay. Once I've got, well, I can't spell minefield yet. You'd think after all these years. So once I have that, I need something else here. Once I've got the minefield initialized, I've got it drawn on the screen, I know where all the mines are, now what do? Well, now I just wait. Right? So I got to wait for some user input. Specifically, when the user left clicks, when the user right clicks, and each time I do a left click or a right click, I'm going to do some stuff. So I'm going to update the screen. I'm going to do that by maybe check the minefield. Mine, update the screen. Update the game status. Again, the whole idea here is I'm not writing the software just yet, but I am sorting out my logic as we go. And it doesn't matter how big and complex this gets. I'm just starting at the top and I'm drilling down. How do I handle when the user right clicks? Right. We're going to check for some mines, right? No mines, start clearing. Because Minesweeper works when you click on a space that has no mines, it just starts clearing until it gets to the border where there are mines, and it stops. Is it? Much easier to change than to fix code. Right? Get the logic right. Okay? Do we have a winner? What do we check before we have a winner? Now I'm starting to seeing some repeating bits already. And those repeating bits, we're probably going to want to write once as opposed to write it multiple times. And that's going to lead us into a specific structure. Okay, let's just start today with how do I create this minefield? So the next part we need is part of the collection of things we call flow control, which is a for loop. And we've all done for loops before. And the magic here in JavaScript is that for loops in JavaScript look exactly like for loops in C++. So and what was my magic number here? Column size. And we're going to create a row inside. So let minefield I also be an array. You can do it this way. You can do it a lot of different ways. There's a lot of different ways that you're going to specify this. Now, each of these rows is not going to have anything in them. So probably what we need in that data structure just some placeholders. Make them constants. Right? And then in each of these rows, let's just put a flag in there for now. Just a placeholder. Let's fix up some indentation here. Okay. Let's go run it through the debugger. Put a breakpoint right at the beginning. So reload it, go to the debugger. It stops right at the top there. Push that console out of the way. And now we can start to watch it actually unravel. We've got our column size. Right? If A is less than column size, you notice it just dropped all the way right down here. It's because A was bigger than column size. And you should also see that when I hover over things in the inspector, it tells me what their current value is. Okay. So now I'm going to set a couple constants. You can see them set on the side here. And now I'm going to walk through my for loop. So row, we start to see block level scoped. So in our total script, we know about A and minefield, but we don't know about I, and we don't know about row. So I'm going to attach that row, right? Now I'm going to walk through in another block, and I can see the row develop. And it has a length attribute. All right. How many elements are in the minefield? 10. Numbered 0 to 9. Origin 0 in JavaScript always. Okay? And do that 10 times. Now, I'm just going to drop a breakpoint here and play it. And drop off the end. And that way, now I have my minefield represented here as a data structure in memory. But at this point, we want to start looking at, okay, so it'd be really cool if I could use some of those kind of for loops to build this HTML instead of me actually having to hard code it. That way, if I changed column size to 25, it would just automatically build this table. Right? So let's talk a little bit about integrating stuff with the browser. When we start, we typically are just writing generic JavaScript, but as you see, you can't get very far without seeing what's going on, and the inspector only gets you so far. I mean, ultimately, we want to build applications and programs that affect the user interface, that show people stuff and react to what they do. So to do that, we're going to have to interact with the browser. And the way we do that is we interact with the document object model. Remember early on we talked about how the web page, when it's loaded in your browser, the browser creates a document object model. It's a data structure. It's a tree. And it's searchable. That document object model is got a variable name. It's called a document. And it's an object in JavaScript, which means it has a bunch of sub-attributes that can be dereferenced with the dot operator. And so when we start managing our web page, we're really going to take advantage of what the browser does for us. And what the browser does for us is it manages that document object. And every time the document object changes, it relays out and redraws the screen. Now it's really smart about this because it doesn't redraw the whole screen. It knows which parts of the document refer to which parts of what's on the screen, and so if you change something in the document, it only changes that portion of the screen. That's how it runs quickly. The structure of that document, you could imagine something like this. So for the HTML on the left there, you have a diagram or a tree structure based on the tags that are used. We've got a document object that has a head and a body section. And inside the body section, I have a header tag, I have a section tag, and I have a footer tag. Which leads us to some of those new HTML tags. With HTML5, instead of using divs everywhere, HTML5 introduced some tags to make it easier to read HTML. Specifically, header, footer, main, and section. There's also nav and aside if you're building pages. Nav being navigation bars or menus. And they have no actual functionality. They behave exactly like a div, 100%. They're interchangeable with a div. But instead of doing div ID equals header, you can just use header. It makes it easier to read. We call this semantic HTML, HTML with meaning. The document object model gets constructed the same way. It builds this data structure. And after it builds this data structure, the browser then reads your style.css file, because it saw it in the link tag in the head section, and it walks through the style.css file, and for every selector that you created, you have a collection of styles. Each selector is thought of as a search term. So if you create a selector for all divs or for the body tag, what it does is it searches for the body tag in this document, and it takes the styles out of your style sheet and overwrites the ones that already exist in the document. When it comes down to classes in your CSS file, something dot and then a name you gave, it goes and searches all of the document, and in every element it looks for the class attribute, and if the class attribute matches your selector name, it takes the styles in that selector and overwrites those styles in the specific document. Understanding and putting your brain around how this document is the holder of all information that you see graphically on the screen is the key to manipulating what's on the screen. In JavaScript, we will manipulate this document to get things to happen on the screen. We will do things like add entire classes, which is the nice clean way to do things. You can grab every element in a section with JavaScript and walk through every div in a section and apply or add a new class to it. And when you do that, the browser will go, oh, these things now all have this class. Let me go check my list of CSS selectors. Oh, there's a selector that matches that. Let me go grab those styles and apply them to these divs because it just changed. And then it redraws the screens based on that. And in this way, the HTML creates the structure for the tree, and the CSS styles are applied to every element. Every element has the full suite of CSS attributes or CSS styles on them. They all have defaults set. When you set up your CSS styles, whether it's in a styles.css file or in the style tag, you're overwriting the defaults. Last guy in wins. That's why it's called cascading. So if you link in style.css and then you have a style tag, the style tag came after the linked in file, so it overwrites anything in the file. If you have a style attribute on a tag, it came last, so it overrides anything in the style tag, which overrides anything in the style.css file. So that's why they call it the cascading style sheet. You can link in multiple different CSS files. In later projects, you'll see me do this as well. I have a style base CSS file. It's not very application specific, but it resets things to defaults that I know. It sets paddings and margins to 0. It turns off the borders. It makes sure the background is a certain color. So I'm starting from a default place. I will link that style sheet in, and then I'll link the style sheet for the application I'm working in. I will probably have a style section in the head as well, style tag. And I'll use that just during development because it's easier than flipping between files sometimes. And then very, very rarely will I attach a style attribute to a specific tag. So how do we work with the DOM? Well, I don't know, you guys, let's take a short break and then we'll come back to how we work with the DOM. We're going to use our JavaScript to manipulate, and I'll show you how. So I'll come back at 11 and we'll start diving into how to do this, and we'll finish up by generating our Minesweeper mine field using JavaScript, not HTML. All right?
the latest like 3 gens, kind of hold your hand for everything. Yeah, but I think
You guys have time to play games, and I need to give you more stuff to do.
and I played that like 3 years ago, 4 years ago. Yeah, for some time I really wasted my time trying to have Pokemon. I have more than 100 ones. So, same here. I have like 2 boxes full on shield and the shinies. All you need. PG22 Pokemon tournament coming up. Pokemon tournament. Let's do it.
Just don't want to get into any middle-aged guys in there. When Magic first came out, I had a couple friends who just went to the store and said, I'll just buy the whole display.
Magic is quite the money thing.
Yes, it is.
Genshin Impact is one. I don't know. I don't think you can buy one single Genshin character for a couple $100. Yeah, that's true.
Well, it depends on what your budget is, doesn't it now?
That's why I don't touch that game.
Yeah. All right. Let's take a look at how we can modify this. So this is the part that I don't need for this assignment. This is the part where we can use JavaScript to start to generate HTML. If we've got that picture in our head of the document, the document object model, we should start to get this picture of how we interact with it with JavaScript. We generate some HTML that generates this document. And when it generates the document, we then load JavaScript in our browser, and JavaScript will create all of the data structures that we need. And later on, we're going to create more of an object-oriented data structure. And that object-oriented data structure is going to then start running. And as it starts running, it's going to initialize some stuff. And after it finishes initializing some stuff, which may include updating the HTML, it's going to set up a number of things waiting for events from the user to happen. And then it's going to sit back and wait. And as it sits back and waits, when the user does something, we're going to react to it. And this is called event-oriented programming or event-driven programming. So we've got to figure out, how do we get our application to handle all of the things that the user is going to do? But before we do that, we need to set up our basic application. And some parts of that application are easier and nicer to write in HTML, and some are nicer and easier to write using some JavaScript. And I like to mix the two up because each language has kind of its strengths and its weaknesses. And writing too much JavaScript to generate HTML makes it very confusing to figure out what the structure of your application looks like. At the same time, exactly as I showed you in the live share, I mean, that big table is just begging to not be written by hand, right? I mean, if the requirements changed 6 times in that live share and the number of table rows changed from 10 to 15 to 25 to 3, it would just be a pain in the behind to deal with all the time. So instead, we're going to generate it in code. Now, we need to know some things first. First of all, JavaScript has access to the entire DOM structure. It can change any HTML element anytime it wants. It can change any attribute on any HTML element. It can change any CSS style on an HTML element. It can add, remove classes. It can add or remove classes to the class attribute on an HTML. It can also create new event handlers to handle any event that happens to any element on the page. In fact, technically speaking, JavaScript's interpreted, which means there is nothing that prevents your JavaScript from immediately changing JavaScript. You could write JavaScript which changes the JavaScript in the page. Now, don't do this, okay? Self-modifying code is a nightmare. Don't go there. But it is possible, because our JavaScript is in a script tag, for our JavaScript to, when it starts running, go find all the strings in the script tag and change them. Right.
One question.
Yep.
Can you change things in about CSS?
Yep.
Okay.
Yep.
Doesn't matter the different folder.
No, because you're not actually changing the files. You're changing the data structure in memory after the file is loaded. Right. Okay. Which leads us to the first part. You know, the JavaScript I started writing is really kind of ugly, sitting at the bottom of our HTML file, and you can see it's already getting long. And it's more than a page long, which means it's way too long already. So the first thing I'm going to do is I'm going to push it out to a separate file so we can edit that JavaScript file. And then the way we do it is really pretty straightforward. In our Minesweeper folder, I'm going to create a new folder called scripts. And inside there, I'm going to create a new file, index.js. Now, what you're really trying to do is tell anybody who's going to work with this where the starting point is for your application. There are really two names of this file that I've seen by convention. There's nothing that forces any particular name. By convention, we usually use index.js. Because we're using index.html, most people will find that index.js is probably the place where your JavaScript starts executing. Also, the other one I've seen is main.js. Both are perfectly valid, right? Now what I'm going to do to start with is I'm going to go to my HTML file. I'm going to take the entire contents of the script tag, including the comments, and I'm going to cut them out of there, and I'm going to put them in my index.js. Slide them over and put a header comment on. Cool, good enough. Now in my index.html, I have to change this script tag. And what we're going to do with the script tag is we're going to tell it where our JavaScript is. Scripts index.js. You have to leave the closing one in there. But that's not all. Now the default for JavaScript scripts is that they are standalone scripts. They are what we call loose JavaScript. And the way I've written mine, it's got a whole bunch of global stuff going on. What I'm going to try and do is get used to using modules. And the way we use a module is we say type equal module. Right. The other type you can use is text JavaScript. That's the default. Okay. But I'm going to get you guys in the habit of using module. And we'll see how that fits together when we start doing more elaborate things. Let me go. Let this rerun. And when I do it, if I look at the debugger, I'll see that under sources, I'm looking at the index file, and I've got no more JavaScript there other than the stuff injected by, the live server. So I can look at the scripts folder now and see my index.js and just get JavaScript there. So that's kind of the preferred way to put things together. All right, we got that all in a separate file. Now we can start getting into, okay, how do we get this stuff to actually interact? Well, when we start talking about interacting with the web, we have to interact with that document object. And there's a bunch of ways to do it. There's the traditional way to do it, which still works and is perfectly valid. It's just kind of long-winded and painful. And then there's a way that was derived based on a really popular library called jQuery. And it's kind of the modern way to deal with things. So the way that you will see in some places on the internet to access things is by accessing the document object and dereferencing using a method called getElementById. Now, this is old, and this is not the way you should do it, because it has some caveats that come with it in the thing it handles back. It hands back a reference to the element, the HTML element. We're going to do it in a sec, so you'll see it in the debugger, what it looks like. Okay. The new way of doing things is to use the query selector. And the query selector uses the same selector syntax as your CSS. The query selector takes one parameter. That parameter is a string, and that string is a selector in the exact same format as CSS. And for this reason, it makes it really easy to pick things off. This is also the primary reason why we put IDs in parts of our HTML code, is because we can use the query selector to select something by ID and get a reference to an element, and we know there's only one of them. If we know there's a list of them, you want to select by class, you can use query selector all, and it will return you a list of elements. And we can change the contents, that is what's in between the tags, using the inner HTML element. So let's dive into the live server and let's go make some of this happen right away. So create a minefield. Now I'm going to start by creating a super simple empty thing. I've got this output div right here to test and play around with. And when I look at that output div, I'll bring this up on the screen, my output div comes below my grid and above the stuff below the fold. So if I put some stuff here, you'll see the output here in my browser. Output here. All right. The inner HTML is this part, the stuff between the tags. So that's what we're going to modify. The ID is output. And the way we would reference that in our style.css would be selector would be hashtag output. We're going to use that in our JavaScript. I'm going to create a variable that represents that HTML element. I'm going to use the document, that's the DOM, and I'm going to use query selector. And then I'm going to use the one parameter, which is a string, and grab the output. The element is an object, and that object refers to this whole thing. Okay. So to modify it, we can change its inner HTML. And you will notice now I have new content because the live stream the live share automatically updated the server. If I share my debugger and we put a breakpoint there before it happens and then reload the page, we can watch it reload the page. Now it's stopped here. If I look at the output, it says output here. I go back to the debugger. It's going to step over that, and the element is going to refer to that particular element. And you'll see it says div hashtag output. That's the search term that we use to go through the document to find that particular HTML element in the document. And you can see all of the attributes listed here. In particular, you can see the style attribute, which is all the current styles applied to that element. Ick, right? But all of those are accessible. They are part of the style attribute of this object. So element.style, way down the bottom here. So element.style.accentColor is a variable you can change, and it's a string. Element.style.borderColor. So you can set any of the styles you want there. A little cumbersome to do. Now let's go grab the inner HTML you see has the value output here. That's what it currently is. If I step over, now it has new content. And when we look back at the page itself, the new content changes instantly. So using this, we can go build new things. We can put styles, we can put HTML, or we can put regular old text as the inner HTML. We look in the live share, and we look at the index.html, I can see here that this table has a bunch of stuff in the middle. And in fact, in order to make this a little easier, I'm going to build this table in JavaScript. So the first thing I'm going to do to make that easier is I'm going to wrap it in div. And I'm going to give that div an ID so I can grab hold of it. And in that table area, I'm going to put a comment. So that when I come and look at this HTML in the future, I know why there's no content in there. All of this is going to go away. So the way I typically do it is I'll cut it out, and I'm going to put it in my JavaScript file, and I will slowly wrap it up. I'm going to cut it out. And we're going to go over to our JavaScript file, and where it says, hey, update the HTML, create the minefield HTML, I'm going to paste it here. Now this is really bad because it's not JavaScript, but we're going to wrap some JavaScript around it. So the JavaScript we wrapped around it, and I'm going to share this on both so that we'll get it in here. The first thing I'm going to do is I'm going to go grab the table area. Okay.
The L is element.
EL, yeah, I use element as a short form of element. I'm just trying to give a variable name that clues my head into the fact that this is an HTML element. Okay. Now I'm going to want to set the HTML to something, but I want to create that something first. So the next thing I'm going to do is create a variable. And I'm going to create a variable that actually contains the HTML markup. And now I'm going to go through and I'm going to go create all of my stuff here. I'm going to comment this stuff out so it doesn't wreck my JavaScript. And eventually, we'll get rid of it. So what's the first thing? We have a table header. Right? And we also have the choice of indenting things if we want to make them line up. What I'm going to do is set them up like this. And I'm going to bracket these things, top and bottom. I'm going to build my stuff in here. And then the last thing I'm going to do, I'm going to take the table area element inner HTML and add that markup. Now, again, structurally, this JavaScript is very, very, very poor because I have a JavaScript file that just goes on for miles. But as we introduce classes and objects, I'll show you how to parcel this out into nice, neat, self-contained pieces. Now, JavaScript is often referred to as a functional language, and I haven't talked about functions yet. And that's because there's zero need to use the keyword function anywhere. And if I see it, I'll just start taking marks off. I don't need it. I don't use it. I'll show you how to do it with objects starting next class. And once we start doing things with objects, you'll find that things are very much easier and more self-contained because you'll write lots of smaller methods that are attached to objects. And those methods being shorter and smaller will be easier to debug than this massive chunk that I'm writing right here. The guts of it will be the same. So in time, the table header, I also have a collection of columns. And how many columns do I have? Column size columns. So let's go reuse this. Right? And for every column, what am I going to do? Add a TD with the column header. And what do we have? Part of the reason I copied this in here is they just have a number in them, right? And inside there, that's what I'm adding each time. This, we put the table header on the close. And I line everything up just to make it pretty. This replaces this. Except if I change the column size, it just automatically grows and shrinks. All right. So this leads me to a word about strings here. There are three styles of quotations in JavaScript, and they mean slightly different things. The double quotes are standard strings that the JavaScript interpreter looks inside. And when it looks inside those strings, if it sees certain characters, it will specifically try and interpret them. In this case, the plus character would be a bit of a problem. can't just add these inside the quotes. It'll just interpret it as a plus sign. So this gets a little ugly to look at. So the other way I can do this is with single quotes. And single quotes in JavaScript are what we call string literals. And that is the JavaScript interpreter doesn't look inside them. So I could do a single quote. Well, that's going to create the same problem. I actually want these to be special characters, and I would need to escape them, which is just as ugly. But JavaScript added another quote style, and it's the backtick character that I use all the time. It's the character right beneath your escape key. It's where the tilde key is. And that backtick character is an interpolated string. It means you can use variables inside there. And you use those variables just like you do with interpolated strings in C#. So the dollar and the two curly brackets inside the backtick characters are an interpolated string, and it replaces dollar curly bracket I curly bracket with the current value of that variable. So it makes for some really nice string handling capabilities. Now, of course, we have a bunch of rows here as well. So we can use the same idea and the same for loop to get all the table rows built. This time we're going to call them table rows. And we're not going to put anything inside them. And of course, inside each row, we have a bunch of columns. But we also have a collection of rows. So we need to wrap all of this in a for loop as well. And now we should have our full table. So we can walk through it in the debugger and see if it actually is going to work for us. Let's shrink this so we can see the whole thing. There we go. All right, so as we start to walk through it, I'm going to throw a couple breakpoints in as we go so I can stop at key parts. So we're going to start, we've got our table area, we've got a reference to it, now we're going to create that markup. Now, one of the things when I'm debugging I'll do is I'll throw in a bunch of breakpoints for things I don't know if they work, and as I prove they work, I'll clear the breakpoints. How do I know the whole thing works? I've got no breakpoints left. So now I'm going to go through this for loop, and I'm going to add this markup variable. And you see the way it fills in the markup as we go? Yeah, you can see it in the debugger.
Oh, yeah. Oh, okay. Oh, I got it.
I haven't applied it to the HTML page yet. I don't do that to the very bottom. Right? So I'm building up a string. I'm putting in a variable called markup. kind of the standard name for HTML markup. And I haven't applied it to my page. I want to apply it all at once. Okay. Now, this is not the only way to do this. There are methods attached to the document where you can add elements as you go. Right? This is probably the more efficient way to do it, because each of those document methods takes time to run. So as you start adding elements, you start have to keep track of the nesting of elements as you go. Whereas here, I've just converted what was HTML in a comment into some code that generates the HTML as a string and then applies the string all at once. So we can see the markup is growing as we go. So I'm going to let that part run. And now I'm going to go grab all the rows, which I'm going to do a collection of rows, and each row is going to have all the columns in it. And by the time I get to the bottom, markup is this one huge run-on string, but I don't care about the formatting of the string. I'm going to inject this into my HTML page. I'm going to add that table tag to make sure it's closed nicely, and then I'm going to throw the whole thing into my document, which now looks exactly like I expect it to look. Now that doesn't mean it's perfect. I still have some things I might want to tweak, like I might want to shift the columns over one. I might want to fill in the 00 element in the header. I might want to put numbers down the side as well. But that's all a matter of modifying the string that is our HTML markup. So now I've replaced, if we look at the live share, I've replaced this ugly chunk of inflexible HTML with a relatively small piece of JavaScript code. And if we change the size to be 12, it just changes without any real work. Right? So that's a good first use of our JavaScript. So I probably want to save that. Now, one of the things I got partway through last time, and a couple things blew up on us. I'm going to take some time to go through. We got you hooked up with Git and GitHub, and you have a repository. You can do all of the work that you need to work with GitHub from directly from Visual Studio Code. But I think if you have a better graphical picture in your brain of what Git and GitHub are doing, it should make your life a little easier conceptually. We use SourceTree as a user interface to Git. You can do Git on the command line. Git is a tool. Git stores versions and copies of individual files. So at this point, I can look through my source control in VS Code, and it just gets really confusing because of the way mine is set up. And I have all of these files that are not checked anywhere. But if we look in SourceTree, for a particular project, let's just look at one of the final projects here. We see an interface, and as much as you can't read the text because it's so small, the interface is pretty much the same. It's trying to tell us information about every version that's been committed. And for everything that's been committed, it tells us which files are in that commit. It tells us what changed in each file exactly. The red things were removed, the green things were added. Right? All the files that were changed, and what was changed, what was added, and what was removed. The little lines on the right give us the ability to have variations, branches, if you will. So one of the things I'd like to share with you is how this kind of fits mentally, picture-wise. So we're going to do that by going back through this. Okay. So the first thing I usually start with is keep your brain wrapped around the fact that source tree is not Git and Git is not GitHub. These are three separate pieces. Source tree is the user interface to make Git easier. Git is the actual tool, and it comes from the incredibly well thought out go get it. Except if you say it fast in English, it's go get it. Go get me this file. Git works on your local computer. Everything on the left-hand side of that dotted line is on your local computer. Okay. GitHub allows us to have a common location to share things. Git as a system lets us push all the changes we stored on our local computer to another computer. Conventionally, what we realized was if I'm pushing to a different computer and someone else wants to work on it, they need access to that computer as well to pull things from it. And so to get that terminology right and get the differentiation right, I put together a bunch of like picture graphs so you can kind of wrap your head around the Git terminology. Okay. Git as a tool is free, it's open source, and it's probably used by more people than any other tool for managing changes to a project. Managing changes without overwriting or losing stuff, without having to make backup copies all over the place, without having to consume your hard drive with 10 different copies of every time something works. So the earlier you get used to using these tools, the more safe you will feel with your software, and the easier it will be when something goes wrong to go through that history in source tree as I showed you and go, okay, something went wrong, someone added something or removed something they shouldn't have, what happened? And you can look at the histories there and you can start to try and do some detective work and figure out, how do I get back to that good working state? It's also very useful if you have multiple people working on a project. And eventually when we get into some team projects, we're going to do this as well. If you're both working on the same file at the same time, you're going to have problems. These tools let multiple people work on the same file at the same time and merge them together nicely. The other thing you end up eventually doing is you eventually will end up writing some software one night that you think is a great idea. What's worse is if you've had something to drink and you start writing those things. And I don't just mean fruit juice. And when you do those things, you will look at them the next day and you will scratch your head and go, what was I thinking? How could that possibly have ever worked? Oh my goodness. And the next thought is a little bit of a panic thought, which is how do I get it back to the good working state it was the night before I started adding this great idea? Right? Without a tool like Git, you struggle to remember what it used to look like across 4 different files. Say you're changing the HTML, the CSS, and the JavaScript, and you spend 4 hours implementing something that doesn't work at all and you want to go back. Git lets you revert all of those changes instantly. As long as you're changing things or committing things on a regular basis. So let's take a look at what it really does terminology-wise, and then the hope I have here is that start using it over the coming week to do your Minesweeper app and use it as an experiment to play with it and get your head in the right headspace around it. So as we do more and more complicated assignments, you'll just get in the habit of every time something works, commit those changes to your source repository, push the changes up to GitHub to save a backup copy of them. So here's the way Git fits together. On the right-hand side, we have what's out in the cloud, some remote repository, whether it's GitHub or GitLab or Atlassian's Bitbucket or whatever. On the left-hand side, we have your computer. You have a folder in your computer for each project you do. The folder should be named the name of the project, right? Don't replicate folder path names. If I've got a VFS GD63 folder, I don't create a project inside there called VFS GD63 project name. Kind of redundant. It just saves me drive space. The little dashed things there are two things that when you initialize a Git repository on your local computer, it creates and hides from you. One of them is a staging area, and the other one is a local copy of the repository. That's the history. Okay. When you first go and clone a repository, we did a git clone operation. That copies the remote repository, which in your case was empty, into the local repository, and it made a copy in your project folder. It did both of them at the same time. One of them's hidden. We have files in there. Files we create, files we add, files we edit. As we work with these files, one of the things we're going to do is make changes in editors. And we're just going to magically work on them in the local files. Okay? We're going to change things and we're going to add new files. We don't have to do any Git-related work. When you go into SourceTree and you stage things, it takes a look through your project folder and it figures out what's different from the local repo and it gives you a list of them. That's what's in the bottom of SourceTree there. When you stage them, it puts them in the staging area. And the reason it lets you stage them is you might change 12 different files, but only 4 of them are related. You did 3 or 4 different things. So you take the 4 files that are related and you stage them together. The idea is that every group of things you stage are what we call an atomic commit. In other words, if I were to remove those changes and those changes alone, everything would still work. So you want to group like things together. Then when you commit those changes, it makes a copy of them in your local repo. That's your backup copy. So using Git does the backups for you, and it's like stacking sheets of paper. Every different commit that you make is like another version of the same file stacked on top of the previous one. Okay, so you always use the same file name. There's no version numbers in file names. There is just the file. And Git keeps track of all the versions stacked up layer by layer. Again, this is all on your local machine, and it's just like playing a role-playing game, right? Every commit is a save point. So every time you got something working, stage commit, stage commit, stage commit. You can commit 100 times a day. Git doesn't care. Okay? Every time you got something working, stage commit. Now, eventually, usually at the end of the day, you're going to want to take those commits and go, you know, if my hard drive died tomorrow, what would I lose? Well, you would lose all the local stuff on your hard drive that isn't backed up somewhere. So how do I back it up? I push those changes to GitHub. And that's that push button in Git in SourceTree. The push button takes all of the staged and committed changes and takes all of those commits and pushes them to the remote repository. Okay. You'll also notice in SourceTree there's a fetch button. What does the fetch button do? The fetch button does exactly what the pull does, except it just updates your local repository. It doesn't actually change your project folder. If you use the pull button, what it does is it pulls from the local repository, it updates your pulls from the remote, updates your local, and then merges those changes into your local repository. If you're working alone, like we are right now, there's nothing to merge. There's nothing that's going to be different because there isn't another person changing things on the remote repository. If you have 100 programmers working on a project, that's 100 people pushing changes to the remote repository every day. So the more frequently you pull their changes and merge them with your own, the more up to date you stay. And the easier those merges are. And by merge, I mean if I write in the top part of my JavaScript file and David writes in the bottom part of my JavaScript file, Git knows enough to stick those changes in together. And because they're in different parts of the file, it'll just happily say, yep, stuff changed. We merged it for you. Everything's good. If they overlap each other, if we both edited the same part of the file and it can't figure it out, it will flag it for us. It'll call it a merge conflict. That's not the end of the world. It just means I have to manually go in and choose, is it mine or is it David's? And or is it a merge of them? I have to go edit the code to make that happen. And all of that is on your machine.
I was going to ask you, we're going to learn how to do that? I've always wanted to know how to do that.
Yeah. Yeah. The merge conflicts, there's really kind of 3 ways to deal with it, right? The first way is in source tree, there's a button. So the files that are in conflict will be in the bottom part of the screen. Down here, the little icons will tell you what happened. The little orange one that looks like a pen means something was edited, right? Scroll down a little bit more. Maybe I can find something.
Oh, we have a lot of branches.
Oh, yeah.
Different colors, I guess.
Well, I'll explain that in a sec. Okay. The little green files with the plus signs, those are added files, new files. Okay. It'll show up with a little warning triangle if it's a merge conflict, and you won't ever see them in the history because you won't let you push them. And where it's got a little merge conflict, you'll be able to right-click. And when you right-click, the menu will be different than the default menu here. And what it will ask you is, do you want mine or do you want theirs? In other words, do you want to keep your own or do you want to accept theirs instead? And if you don't like either of those options, you can open that file up in the editor and edit it. So for source code, JavaScript, C#, C++, you probably want to edit it. For all other kinds of files, binary files, art files, 3D assets, you need to choose either keep mine or accept theirs. That's it. You right-click the button and say, accept theirs. Merge conflict gone. Okay. Once all the merge conflicts are gone, you can then commit those changes by staging them and committing them into your local repo. And when you push, they'll go back to the remote repository. Okay? So, the merge only really works for text for source code. It's always on your machine. So once you merge things and supposedly resolve the conflicts, you should rerun your application and test them again. With HTML, it's really nice because everything we do, or most everything we do, is text files. So it will happily merge things for us. Okay. Once you have all those things resolved, right, then you can turn around and do the whole normal commit or stage commit push. Right. All of those things happen locally. Now, on top of that, we have the ability to create what we call branches. And those branches allow you to have a version or a variant from the standard version. By convention, what we typically do in Git repositories is we have a main branch. And that main branch is what we release to the world. That's our product. We obviously don't want to mess with that. We want it working perfectly at all times. So we'll quite often create a development branch that people do all the development work in. And what you saw in source tree on my machine there was one of our term projects with lots and lots of branches, because what we often do is create a branch for every feature where we have lots of different people working on stuff. You fork off a variant to build your feature, like your own little local sandbox. When your feature's good and working, you complete the feature and merge it back into the develop branch. And at the end of the milestones or the end of the time period for working on your project, you merge it back into main and you release the main branch. Obviously, you test at each stage. So if we're looking at how branches fit together, we can kind of follow this picture. I've got a file and I've got version number 1. So that goes into the main branch. I add it, I commit it, I push it. I'm all good. And I make some edits, I make some more files, I stage, commit, push them. Main looks great. Okay. And when you pull, we're pulling those main branches. At some point, right, I'm going to have a bunch of changes I'm going to make. Remember, these are all versions of the same file name, same folder. We're not creating different folders. We're not creating .v1 or .v2 or some other crazy naming convention. Now, at some point, David comes along and starts to work on a version of his own that's slightly different than mine. So over into the develop branch he goes, and he pulls version 3A, and he starts working on it and making changes. His changes are sitting in that development branch. Number 3 is still sitting back in the main branch. He makes some more edits. Version 3B, it looks pretty good. In the meantime, I mess things up and I go make some edits to version 3 as well in the main branch, and that would be number 4, just following the naming structure there. So now I've got version 4 and David has 3B there. So at some point we have to pull those together. So what we do is David merges the main branch into his branch. So he merges my version 4 changes into his 3B. He makes sure it all works, and then he pushes his changes back into the main branch. Okay? And that becomes version number 5. And then we can both pull version 5 and carry on our work. So this way we'll use branches. Now, as you work on your Minesweeper project, to just work in the main branch is fine. If you want to create a development branch and work in it, that's cool too. When you submit your assignments, I'm going to ask for a README with a description of what's not working, caveats. I'm going to ask for the first thing is I'm going to ask for the URL for your GitHub repo where I can pull your code from. And not only that, you're probably going to have to tell me which branch you want me to pull. So don't assume I know. Don't assume I'm always going to take main. If you say, here's the URL to my repo and I want you to pull the develop branch, then that's what I will go get and look at. Okay. Now you can use this to your advantage. If you just tell me to go get the main branch and you build away in the develop branch and you commit changes to the develop branch, it can always house kind of the latest, greatest. You can also create branches as you need them. Now, further down the road, we'll introduce you to a topic called Git Flow, and it's kind of a set of predefined actions that you can do that do this branching, pull, push thing automatically when you want to create new features and new releases. But it's just a shortcut for doing a bunch of these things manually. So what I'd suggest you do at the end of today is, if you followed some of this stuff along, is try and make your local copy work with your Minesweeper branch or your Minesweeper repository. You probably want to push to the main branch your Minesweeper HTML part and then create a branch using the branch button called develop and do the JavaScript part in the develop branch. And then tell me to go get the main branch. That way you can work away in the develop branch and not change and not mess up your HTML. Remember, in that develop branch, you can go mess with anything and everything. If I'm pulling the main branch, I'll pull a different version. So you can use this to manage which things you're submitting when.
I push develop into main when everything's done and
yeah. You don't push one branch into another, you pull one branch into the one you're currently in. That's one thing. Yeah. You want to go both ways. Like that's kind of the reality if you kind of step back and look at the logic. If I'm working in develop, what I want to do is I want to pull main into develop just in case anything changed and get me up to date. And if that all works, then I want to go switch into the main branch and then pull develop into main. It's a multi-step thing. That's why the git flow thing kind of works for us, because it's a bunch of shortcuts that do exactly that for you, but just with one button press. Just helpful to have in your head what happens. Does that make sense? Kind of, as a first draft. I'll put the slide decks up. Okay. You will see this slide deck again in term 4 when we do technical pre-production. But you'll be so used to Git by then that I am literally going to get you tasked with helping the game design students wrap their heads into it. Okay? So you're going to teach them. They will see it for the first time in term 3, where they do team project. Actually, you'll be there as well. So that's probably the first place that you will be teaching the game design students how to use Git and source tree. So you got 4 months to become an expert.
Yeah. And hopefully by then you'll be in person.
And hopefully by then you'll be in person. Well, I don't know. What's the advantage of being in person again? Okay, for Andre, it means you're not working in the kitchen.
My living room kitchen. Okay, so it's a bit of both. Yeah. Oh my god. Everything's patched up and you gotta extravagance.